So hello students, welcome back to the online lecture series for RCC. The topic for today's lecture will be column. So let's start. As you all know that column is a vertical building member. It is axially loaded compression member because the compression load is there, whose effective length is more than the 3 times of its least lateral dimension. So this is the point from which you can identify a column. So its effective length should be more than 3 times of the least lateral dimension. Least lateral dimension B and D, whichever is the minimum, you will multiply it by 3, and it should be less than the effective length, that is L. So here is the formula. L effective, it should be greater than 3 times of least lateral dimension. In this case it is the D part. So here is the figure for columns. It is the lateral part of the column and this is the longitudinal part of the column. Here the main reinforcement is provided in the longitudinal direction. Okay, so there are certain components for a column. First one is the pedestal. So it is the axial compression member whose effective length is less than the 3 times of least lateral dimension. So if the least lateral dimension multiplied by 3 is greater than the effective length or the length, then that particular member will be known as pedestal. So there is a difference between pedestal and column. Column is the length should be greater than 3 times least lateral dimension, and for pedestal it should be opposite, means L should be less than 3 times the least lateral dimension. Third one is strut. So it is an axial compression member in a truss. So strut is found in the truss, which may be inclined, horizontal or vertical. So you must have seen in that this is a truss. So these are the struts provided. It is inclined and it can be vertical, and can be vertical also, it can be horizontal also. So as for the classification, columns are classified in 2 categories. First one is the short column, second one is the long column. So based on its dimension, short column, if the L effective divided by least lateral dimension is less than equal to 12, then this is known as a short column. So L effective can be calculated from 3 times the least lateral dimension, and if L effective by least lateral dimension is less than or equal to 12, then that particular column is known as short column. So short column are generally stronger than the long column, but it failed due to crushing. Lateral dimension is less, so it fails in crushing. For RCC column, there are certain terms which are used. So first is the slenderness ratio. It is noted by lambda. Ratio is L effective by least lateral dimension. If slenderness ratio is less than equal to 12, then it is a short column. And for which material? It is for RC. In case of steel, if you are using a steel column, then slenderness ratio lambda should be equal to L effective upon least radius of gyration. So here least radius of gyration means R minimum is calculated by under root I minimum upon A, and lambda is L effective upon R minimum. So for steel column it will be little change, it will be divided by least radius of gyration, that is R minimum. So according to IS 800, this is the IS code for steel structures. So lambda should be, if less than 30, then it is short column. If lambda lies between 30 and 90, means it is greater than 30 and it is less than 90, then it is known as a medium column. And if lambda is greater than 90, it is known as long column. So this is only for the steel part. For RCC it will become lambda should be less than equal to 12. Now the second type of column, as per the dimension, it is long column. Long column can be defined as if L effective upon least lateral dimension is greater than 12, then it is known as long column. It fails in buckling. And the first one, that was short column, it fails in compression. And on the basis of loading, these columns are defined as, first is concentrically loaded column. So here the word concentric means the total load will act at the CG of column and it is subjected to only direct axial stress. Here you can see that load is acting at the center of the column or at the CG of the column, and it is only subjected to direct axial stress. Second one is on the basis of loading eccentrically loaded columns. So eccentrically means if the total load acts at a distance from CG, it means it is not acting at CG, it is acting at a distance away from CG. It is noted by X. Let us suppose it is acting at X distance from CG. So in this eccentrically loaded column there are two types of bending. First is unaxial bending and second one is biaxial bending. It is subjected to direct stress plus bending stress. So there are two types of stress acting on eccentrically loaded. First is direct, another one is bending stress. Also eccentricity is denoted by E and it is the distance between CG to the force. So that's all for today.